Welcome to homework.
We're asked to figure out, well, we have this voltmeter here that has some internal resistance of 5,000 ohms. And we're trying to measure the voltage drop across this resistor here. So we have a voltage supply over here that has an internal resistance of 100 ohms. Then we have these two resistors here that are in our circuit that have resistance of 300 ohms and 250 ohms. And we're told to ignore this ammeter in this problem. So we can do some loop equations. So we have this loop here. And so we have V minus I2R2 minus I1 times R1. So we have some current going this way, some current splitting up here. And then coming back here, we also have I2, so we have minus I2 times little r, and that has to be 0. Then the loop around here says that minus I3RV plus I1R1 equals 0. And then, at this junction here, we know that I2 coming in has to equal I1 plus I3 going out. So what we have here is 3 equations and 3 unknowns for all of our i's. So I'm not going to go through the algebra here, but we can figure out what I1 is. And what we want is this voltage drop here. So that voltage drop is I1 times R1. I1 is this value here. So we can figure that out from these 3 equations. Now, they said, how much error is there by having this being a finite resistance, so 5,000 ohms. Well, we can see here, if RV goes to infinity, which is what we really want, we want infinite resistance so we don't get any current flowing through our voltmeter. So we basically just measure the true voltage drop across here. If RV goes to infinity, then this thing becomes much bigger than this thing, so this is negligible. And then we can see RVs drop out. And so we just get that we have R1 times V all over little r plus R1 plus R2. And plugging in values, we get that is 15 over 13 volts. So 15/13 volt is the true if this were a perfect voltmeter. But in fact, it's not a perfect voltmeter, so RV is 5,000. So if we plug that into here, we get 75 over 67 volts. Now, if we want to know what the percentage error is, we take V1 prime minus V1 all over V1 prime. So this is the voltage we're actually reading. This is that true voltage. So we take the difference and divide it by the true voltage, or divide it by the voltage we're reading, and we get that is minus 0.030 or minus 3%. So we have a 3% error. It's basically a 3% difference between these values. I didn't calculate them out in decimal, but let's see here. Let's see if we have 15 over 13 and 75 over 67. So, slightly we got 2 decimal places basically of accuracy. And so if we want to get more accurate, we would just try to get a bigger and bigger resistance here. We could actually put a very large resistance over here too, and add a resistance to the internal resistance of the voltmeter to try to basically bump this up and make this very large, so that we get very little current flowing through here. So that's how we get this error down to a smaller value.